Now, let's see numerical problems on resistances in series and parallel. Okay, so the first problem, see, there is a circuit which has been given for you, and you are supposed to determine R equivalent for this one. See, there are so many resistors 1, 2, 3, 4, 5, 6, 7. You are supposed to carefully identify which of them are in series and which of them are in parallel. And then you should minimize the circuits. So let's start now. See, this is your circuit. Okay, if you carefully see, I'll start from here. Are these two resistors in series? No, because the current which is flowing, it is being divided into here and here. So they are not carrying same current. Are they carrying same current? No, they are also not carrying current, right? Now these two, no, they are not carrying same current. These two also not carrying same current. But these two, if you see, they are carrying same current, which means that these two resistors are in series. If these two are in series, what is the equivalent value? It is R1 plus R2, right? So it is 1 plus 5, it is 6. And the other set, see, 6 ohms and 3 ohms. Are they in series? No, they are not carrying same current, right? But see, 6 ohms is connected between this point and this point. 3 ohms is also connected between this point and this point. Both are same, right? Which means that these two are in parallel. This is what I said to you. If they are connected between the same points, they are considered to be in parallel. So what is the equivalent value? 1 by R equivalent is equal to 1 by 6 plus 1 by 3. What is LCM, guys? 6, 1 plus 2, it is 3 by 6, it is 1 by 2. So R equivalent is equal to 2. So now, for these two resistors, I can replace it with 2 ohms. For these two resistors, I can replace it with 6 ohms. See, these two, I have replaced it with 2 ohms. For these two, I have replaced it with 6 ohms. Understood? Now, if we move on further, see, how are these two? These two are in, they are carrying same current. So now these two are in now, they are in series, right? So what is the equivalent value of that resistance? Yeah. What is the equivalent value? 2 plus 2, it is 4, right? The next step now. If you carefully see, what you can infer now. These two, how are these two now? These two are in, they are connected between the same points, right? This is also connected between the same point, which means that they both are in parallel, isn't it? So if they both are in parallel, what is the equivalent value? 1 by R equivalent is equal to 1 by 4 plus 1 by 6. What is LCM? 24, right? So 6 plus 4, it is 10, 10 by 24. So what is R equivalent? It is inverse, 24 by 10, it is 2.4 ohms. So those 2.4 ohms. Now, see here, all three resistors now, if you can carefully see, they are carrying same current, isn't it? So what I can do? I can add them directly. They are in series, right? So 4 plus 2.4 plus 8. So what is the value? 4 plus 8 plus 2.4, 14.4 ohms. This is how you will solve the problems. So, series, how to identify whether they are in series? Same current must be flowing. How to identify whether they are in parallel or not? They must be across same ends, or they must have same potential drop across them. Okay. So now we will move on to the next problem. Now if you carefully see. Now, how many I say? 1, 2, 3, 4, 5, 6, 7, 8 resistors are there. So now can anybody identify? See, first you can easily say these two are in, they are carrying same current, right? They are in series, right? Next, see here. This resistor is between this point and this point. Whereas this resistor is between this point and this point. This point is also the same as this point, isn't it? So 4 and 12 are in parallel, right? So let us solve this one. So 1 and 5, they both are in series, so I can replace it with 6. And 4 and 12, they both are in parallel, right? So 1 by 4 plus 1 by 12. If I solve it, I'll be getting a value of 3 ohms. So that's why I have replaced with 3 ohms. Similarly, see these two set also. 3 ohms is between these points. 6 ohms is also between, right? It is also between the same. So 3 and 6 are also in parallel. So 1 by 3 plus 1 by 6. So what I'll be getting? 2 ohms. Understood now? Your eyes must be very sharp that they should easily identify whether they are in series or parallel. 2 ohms. So this is the simplification. Now the next step of simplification, if you carefully see. Are these two in series? No. Are these two in parallel? No, because this is between these points, whereas this is between these points. But whereas these two, they both are in parallel, isn't it? 6 ohms is also between the same points. So what is the parallel value of these two? 3 and 6. It is 2 ohms, isn't it? So that's why this 3 and 6, what I have done, I have replaced with 2 ohms. So the next step now, 1 and 2 are in series. So I can replace it with 3 ohms. The next step is 2 and 3 are in parallel, isn't it? So if 2 and 3 are in parallel, what is the value? 1 by 3 plus 1 by 2. I'll get 1.2. The next step, both are in series. So I'll get 11.2 ohms. Understood now how to solve the problems. So it's about your eyes. Your eyes must be very fast, that they must be able to identify whether they are carrying same current or whether they are between the same points. So what is the conclusion? Resistors carrying the same current are considered to be in series, and their equivalent value is this one. Whereas the resistors which are there between the same points, or the resistors having same potential drop across them, they are considered to be in parallel, and their equivalent resistance is this one. Okay, so with this, I hope that now you are able to determine the equivalent resistance for series and parallel combinations of resistors. Now, we will solve these problems in the class. You try to practice them at home and come to the class. If you are not able to solve, then we will solve them in the class itself. Okay. So I have given you 3 problems for you. So a little bit complex problems. You should try them at home. Okay. So thank you. We'll meet again in the class.